Graph each function, give the domain and the range. If we look at the index here, we have a 3, so if we have an odd index, we have no restrictions on what could be in the radicand. So for that reason, we can select any number to go here. Now, because we have a 3, it's easier to select the perfect cubes. So if we list a couple of negative and positive perfect cubes for x, we can start with -8, -1, 0, 1, and 8. So to find the f of x is equal to the cube root of x plus 4, so we're going to replace the x value with -8 and -2 and so forth. So we get the cube root of -8 plus 4. Now the cube root of -8 is equal to -2, and -2 plus 4 is equal to 2. So here's our y value for the first one. Now the cube root of -1 plus 4, so the cube root of -1, this part here, is equal to -1. -1 plus 4 is equal to 3. The cube root of 0 plus 4, so the cube root of 0 is 0 plus 4, that's equal to 4. And then the cube root of 1 plus 4, that's equal to 5. And the cube root of 8 plus 4, that's equal to 6. Now be really careful with this one because remember this is the cube root of x and it finishes there. So we have to do this part here first and then to the answer we're going to add 4. So now let's graph the order pairs. We have -8 and a +2. So I'll draw my graph. So -8 and +2. So I'm right here. And then -1 and +3. And then 0, 4. And then 1, 5. And 8, 6. And then we connect our dot. So it'll look something like this. So this is a cube function, and this is typical of a cube function. You have like an S kind of thing. Sometimes you have a vertical S, sometimes you have a horizontal S. Now to find the domain, this extends forever this way, and this extends forever this way. So the domain to cube functions would equal to from -infinity to +infinity. And the same is true for the range because it just goes on in both directions. There's no restriction for x or y's. So the range is also from -infinity to +infinity.